So first of all, thank you very much for joining me. My name is Efi. I'm a Director of Engineering in Lomigo. And in the next 30 minutes, we're going to talk about 7 things you need to know before going to serverless. I'll be honest with you, it's more than 7 things. Unfortunately, we have only 30 minutes, so I managed to pack as many tips as possible into those 30 minutes. I tried to cover the entire life cycle of a developer. So without further ado, let's start. So who am I? In the past 12, 13 years, I've been developing, managing software teams, mostly working with backend and mobile. In the past 2.5 years, I've been working with serverless, again, mostly with Python, with Node.js. Actually, my main expertise is building serverless teams. The entire workflow, development, hiring the best people, CI/CD. So if you have any question about that specific subject, that's not what we're going to talk about right now, you're more than welcome to contact me. And on my spare time, I like to blow things up. So if you like card games, you can ping me. So who is Lomigo? Actually, I'm going to say it many times during the session. Serverless, especially serverless architecture, is becoming complicated very fast. A lot of microservices, a lot of Lambda functions, a lot of external resources and services that you use, Kinesis, SQS, SNS, you name it. And in order to understand what's going on during a problem, whenever you need to debug your code, in order to troubleshoot, or what happens in your environment is very difficult, and that's what we do. We provide a platform that enables you to do that. So the 7 things we're going to talk about, as I told you, I'm trying to cover the entire life cycle of a developer. We're going to talk about design, development, testing, deployment, monitoring, tracing, and learning. Okay, so without further ado, the first thing, design. So I don't think, oh, by the way, before starting, how many here developed or is developing in serverless? Excellent, okay, quite a lot. So I don't think there's any serverless developer that didn't hear these 2 dreaded words, cold start, no matter if you're developing in AWS or any other serverless development. And so let's try to understand what is cold start. So how AWS Lambda works. Whenever a request comes, the first thing that happens is that the Lambda service downloads the code, starts a container, initializes the code, and then your code is ready to accept the request and execute it. The time it takes between downloading the code up to the point where it's ready to get executed, it's called cold start. So in some situations, it might take up to 15 seconds, which is a lot. The real question is, how many times does it happen? So let me ask you a question. Let's say you have a running Lambda that executes one of your requests. And let's say it takes 5 seconds to execute the request. And then another request arrives at the same time. And because each Lambda can execute a single request, it means you need to start another Lambda. Will that Lambda have cold start? Who says yes? Who says no? Okay. Who says I don't know? Excellent. So the answer is it will have cold start. It means that if your workload has a lot of spikes, for example, I don't know, during the day you have a special sale or something like that, and you have a lot of customers clicking on your website, then you'll have a lot of cold start Lambdas, which is, depending again on your situation, can be troublesome. So I think the first question you really need to ask yourself, is it relevant for you? So it depends, as usual. If you have a Lambda that is connected to a search button on your website, there's a good chance that it's important because you don't want your user to wait 30 seconds until it receives back an answer. Or on the other side, if you have a Lambda that is running in the backend, batch processing, or I don't know, doing some kind of smart manipulation behind the scene, in such case, probably cold Lambdas or cold starts doesn't interfere, although you're going to pay for it. I don't know, let's say another extra 15 seconds of payment. It's not that Lambda usually are very cheap, so it's not what's going to break you. So let's say you've decided that it's relevant for you. So what can you do? There's one solution, and the solution is called keeping your Lambda warm. What do I mean by keeping it warm? When you have a container that is running your code, that is running your Lambda, AWS is trying to optimize it. What do I mean by optimize it? It tries to keep it alive as much as possible. So as long as the Lambda running, it will keep the container and your code, your initialized code alive, and it will keep it alive for another 10 to 15 minutes. By the way, I don't know the exact time. I don't think that anyone knows. It's a trade secret. It means that if you call your Lambda or you execute a request every 10 to 15 minutes, your container will stay alive, and it means that your Lambda will be warm. You won't pay for those extra cold starts. The biggest problem with that solution is that, again, if we're going back one slide where I talked about your spikes, if you have spikes, then keeping a single Lambda warm is not enough, and probably you need a much better solution. But if you have a single Lambda and that you want to keep it warm, alive, you can either use free tools that are available on the internet, or you can build your own solution. Just make sure to ping that Lambda every 5 to 10 minutes, and you'll keep it warm. Another solution is, of course, reducing the package size. If you remember, the cold start time happens because the Lambda service downloads your code. So if it needs to download 100 megabytes, it probably will take longer than downloading 1 megabyte of code. So keep your packages small. Another thing is actually reducing the initialization time. So if you remember, cold start happens because you have either big packages or because it takes a lot of time to initialize the first initialization. From a research we've done in the past, we found out that initialization probably takes much more time than the package downloading. What do I mean by initialization? So, for example, you have a package that when it first boots up, it downloads code from S3 or downloads something from S3 or fetches information from your DynamoDB instance. In such a case, it will happen each time a Lambda starts. So I prefer to use libraries that do minimal initialization. Prefer light languages. Java, .NET, those are old school languages, which means that they were used mostly on EC2s, real servers, don't say that word here, or VMs. They were designed for a situation where you boot your code, I don't know, once per week if you're lucky, or once per 5 minutes if you're not. And it was supposed to run for a very long time. Lambda and serverless is different. Your code initializes every time you have a new request. It means you need fast languages, languages that don't take a lot of time to initialize the code, initialize their infrastructure. Next thing, Lambda concurrency. So I think that many people, when they're working with serverless, think that serverless has infinite scalability. Guys, that's not true. Every service in AWS, serverless service in AWS, has its limitations. You can't do 1 million requests to a DynamoDB table at the same second. You'll probably hit a limitation. You can't have a file larger than, I don't know, a couple of terabytes in S3. You have a limitation. So I think that first thing you need to do before using a new service in AWS is understanding what's their limitation. Each service has a special page about limitation. You need to read it, making sure that it won't affect your flow, your workflow, your workloads. Lambda is no different. Lambda also has limitations, and one of the limitations is the number of Lambdas you can run concurrently. Sure, it can be a big number. It can be 1,000. You can increase it to 10,000, and I don't know even what's the maximum number you can run, but you still have a limit. It means that if your limit is 1,000 concurrent Lambdas, and in trying to run the 1,001 Lambda, you get an error. You'll get an execution error. And depending on your workflow, it can be very dangerous because it means that some of your code is not getting executed. So the first thing you need to know probably when dealing with Lambdas is how many concurrent executions are you going to have in your environment. So there's a simple equation. It's the average time it takes you to execute a request multiplied by the number of requests you're going to have in parallel. So for example, it takes you 2 seconds to execute a single request, and on average you think you will get 2 requests per second. It means that you probably need 4 Lambdas available running concurrently. Well, that's easy when your workflows are simple, when you have an API gateway calling a Lambda. But serverless, as I said earlier, is becoming very complicated, very fast. What happens when you have DynamoDB streams, Kinesis, Athena, all kinds of other services? Okay, so, and all of them are triggering different Lambdas. How do you calculate the concurrency that you need? Well, load testing, guys. The solution that worked on old school code is also the same in new school code when dealing with serverless. So run load testing. You have free tools on the web. For example, Serverless Artillery, which I think is great, enables you to quickly bombard your code behind the scene and understand how many Lambdas are running when you're running your code. Make sure you don't do it in production, of course, like I did. So one of the things you probably want to know when doing the load testing is, okay, I'm doing the load testing. How do I know how many Lambdas are actually running concurrently? So you actually have 2 metrics that you can use. One of the metrics is called concurrent executions. Again, it's a metric. By the way, I didn't tell you, you have 1,000 Lambdas per each region in AWS. So you have 1,000 for US East 1, 1,000 for US West, and so on and so on. So concurrent executions tells you how many concurrent executions you have at that moment. So you can use these metrics, first of all, to get the number of concurrent execution, and you can create alerts on them. So for example, you can be very proactive. Let's say you've decided that you have a maximum of 2,000 concurrent execution in that specific region. You can create an alert for whenever the concurrent execution reaches 1,800 Lambdas, ping me. So you can be proactive and you know that probably you need to do something about it. Another interesting metric is called throttles, which actually tells you, you can put that specific metric on each of their Lambda functions, and it will tell you how many times that specific Lambda function didn't run because there weren't enough slots for running it. So for example, if you have important flows where you want to make sure that they are always running, and in case you have a problem there, you want to know that fast, then you can put a metric and you can put alert on that Lambda function. So what happens if you need more Lambda concurrency? So the simple solution is actually asking. Just ask AWS. You can increase the limitations. There are soft limitation and hard limitation. A number of concurrency Lambdas is a soft limitation. It means you can actually open a ticket for AWS and ask for an increase. Again, remember, you need to give a number. So you can't write, there's no option in drop-down that says indefinitely. You have to choose a number. And my recommendation is actually the moment you have an AWS environment that is used for production, automatically go and open a ticket and ask for increase in your concurrent Lambdas. You don't have to wait to reach that 1,000. And by the way, it's free. So, and you don't pay for the extra increase. So if you remember the equation you saw earlier, it's in order to calculate the concurrency, it's the average number of it takes to execute a request multiplied by the number of requests per second. So one thing you can do is to optimize the code. Instead of running 5 seconds, you can do all kinds of manipulations and run it in 2 seconds. So by doing that, you reduce the number of concurrent Lambdas that you use. Another option is, of course, changing the architecture. So many times you can use different components, different services in AWS in order to use less Lambdas. For example, you have an API gateway that does a call against a DynamoDB. So what happens is you have a call, then you have a Lambda that is running, doing the query against DynamoDB and returns a request. But what happens if the request most of the time doesn't change? So just running the extra Lambda is not useful. So you can use instead caching. Put cache in the API gateway. You're using a different architecture. And instead of calling that extra Lambda, the API gateway returns the response very quickly. And last but not least, and something that people forget, you can use limits on the Lambda itself. Many times people, right now, Lambda itself has a limitation of 15 minutes. It means that it can run at most 15 minutes, and when the 15 minutes are over, it will kill itself. And many times people use these 15 minutes, the entire 15 minutes, in order to run the request. But there are many times that you know that if, for example, let's say you have an API gateway calling a Lambda, and you know that after 10 seconds, if there isn't any response, it's probably a dead request. Okay, you probably can kill the Lambda and return an I don't know, an answer to the front telling that there was a problem, and the front can retry. So use these limitations in order to reduce the time it takes for Lambdas to run. Okay, so let's talk about development environments. So many people ask me, you know, when you have developers, probably they want to test the code. I hope so, at least. And in order to test your code in serverless environments, and by the way, we're going to talk about it a little bit later, you need to test it on a real environment, a real AWS environment, at least once, just making sure that everything works. And many people ask me, what's your recommendation? Should I use a single AWS environment shared by different developers? Or maybe I should use an environment for each developer? So let's try to understand a little bit about the pros and the cons. So let's talk about the shared environment. How a shared environment looks like. You have a single AWS account where you're differentiating between the different developers according to prefix, tags, and so on. So you have, for example, Mike underscore, and so on, and you have John underscore, and so on. So when someone has a problem in their Lambdas while developing, they can go to that specific Lambda that starts with their prefix, search the logs, and so on. So I think that the best pro about it is the fact that it costs less. Again, depending on your workload. So if, for example, you're not 100% serverless, let's say you have resources in your environment that are managed resources, like RDS, or probably anything that is behind the VPC, like Elasticsearch, or any other solution that AWS provides. In such cases, you are going to pay for these instances, even if you don't use them. So it's not 100% pure serverless, and some workloads have that instances. So in such cases, using a shared environment is much cheaper, because then you'll have a single database with multiple tables in it, each table with a different prefix. But I do think that the con is the fact that it's very hard to manage. Think about it. You have a single environment with multiple developers logging into it, changing things in it, stepping on each other's toes, playing with different parameters, searching, for example, CloudWatch, when you have a lot of logs, when you have a lot of log groups, it's become a bit difficult to find the log that you are looking for. So the next option is using an environment per developer. So again, it's the other way around. So for example, cost. If you are not 100% pure serverless, it means that each developer will have its own instance of an RDS database, which again costs more money. But I think that in the end, it makes the development a lot easier. Instead of stepping on each other's toes and interfering with each other's work, each one has its own environment. And today, AWS has very nice tools for managing this kind of environment using an organization. And in the end, you know, I think that paying an extra $20 per month per developer for managing that RDS instance is way cheaper than reducing the speed of development per developer, the agility. So I prefer my developers to work faster and pay another extra dollars per month instead of them working slower and save those $20. So my recommendation, and that's what we do in Lumigo, we have an environment per developer. And I think that, again, I said that I'll repeat it a couple of times during my session. Serverless environments are becoming complicated very fast. And I think it's very important, especially when new developers arrive to your team, to let them understand how your serverless environment looks like. So I really recommend maintaining a visual representation of your environment. You have great, by the way, really beautiful Cloudcraft, for example, gives you a very beautiful visual representation. It's very hard to do it manually. Again, over time, it's like documentation, okay? So over time, the documentation loses touch between the actual code and how the real architecture looks like. I do recommend using all kinds of tools. I can't say the exact names, but I'm pointing on them. They do it automatically for you. Okay, the next point, testing. So I can summarize this entire section about testing in a single bullet, and it's called test in the cloud, not locally. So yes, on simple workloads, testing locally is probably the easiest thing to do. Again, you have an API gateway, calling a Lambda, calling a DynamoDB. You have great tools today which enables you to test these workloads locally on your computer. But very fast things become complicated. You are adding a Kinesis, S3, multiple DynamoDB tables, multiple triggers for your Lambdas. And the moment you reach that position, it becomes very difficult to test it locally. Not because there isn't any tools. There are great mocks, by the way. It's the problem that mocks usually are not identical to the way the services behave in the real cloud. Many times, mocks have their own bugs. It happened to me more than once that instead of writing the code, and I had to debug the mock itself in order to understand why something doesn't work. It worked when I ran it in a real AWS environment, but it didn't work when I ran it locally. And I really think that in the end, the best thing to do is to test things in the cloud at least once. Again, write your own unit tests, it's very important, but make sure that you run at least, when writing a new feature, run it at least once in a real AWS environment. Deployment. Okay, so again, serverless becomes complicated very fast. I think that whenever you do a change in your code, make sure you are doing gradual deployment. What do I mean by gradual deployment? It means that, for example, if you're changing a couple of services at the same time, make sure that you are changing one service at a time, not everything at the same time. And actually, AWS have a very nice solution for gradual deployments, and it's called Canary deployment. It's called Canary, I think, in API Gateway, which it enables you to actually direct some of the traffic. Let's say you can define the percentage of the traffic to the new version that you have uploaded. So for example, you've uploaded a new Lambda that is connected to an API gateway. You can tell AWS, please, only 10% of the requests, direct only 10% of the requests to the new Lambda, and the rest of the 90% direct to the old Lambda, to the old code. And by doing that, you can slowly understand whether the new code affects your production. Do you have any new bugs or, I don't know, any production issues? And over time, you can increase the percentage up until you reach 100. In Lumigo, for example, we're doing it a bit differently. Again, because the gradual deployment, the Canary deployments work well when you're using API gateways and Lambdas. But again, in cases where you have DynamoDB streams, Kinesis, SNS, and SQS, it becomes complicated. So actually in Lumigo, we have a separate environment, which is identical to the production environment. and it uses the same data that goes through production also goes through that environment, and we are changing the code first in the extra environment. We see how it behaves there, and then we see that everything works well. We actually update the production itself. Infrastructure as a code. We have many great tools today to write your infrastructure code. It means that, for example, provisioning a new resource, provisioning a new server. You can do everything, all the provision, through various tools that you have today, and can be part of your actual code. Things like the serverless framework, things like AWS SAM, Terraform. There are a lot of great tools today, so avoid using bash scripts in order to provision your environment. Use, and that's the norm today, use tools that are ready and available and they are working with serverless. I think it's very, and it also relates to the previous point of an environment for each developer or a shared environment for all of the developers. Make sure it's easier for each developer to provision the code. So you can easily click on a button, either in Jenkins or in any other CI/CD tool that you have, or through the bash script. Click on enter, and automatically run behind the scenes everything that you need in order to provision the environment. If it won't be easy, developers won't test the code, because they will test it locally, they will run unit tests, making sure that things work. But if it becomes very hard for developers to actually test the code in an actual environment, they won't do it. Monitoring. So CloudWatch is great. I really love it. I think it's a great tool. CloudWatch logs, by the way. I think it's a great tool when you have low volume, okay? When you're talking about production environments, when you have many users working with your system, at that point, CloudWatch logs become a bit complicated to search, to filter, things like that. So I think that the best thing you can do is actually stream your logs to an external tool. It can either be an ELK solution within AWS Cloud. It can be done very easily. You have an option through the log group in CloudWatch to click stream to an ELK, and it's done automatically for you. Or you can use external tools like Logs.io, and there are a lot of other tools that enable you to stream your logs from CloudWatch directly to them. Use it. And I think you need to define alerts. Make sure that whenever you create a new Lambda, you automatically create a set of alerts that I think you need to define whenever you're uploading a new Lambda to production. So for example, if you have errors about a certain threshold, let's say 80% of all invocation of that specific Lambda fail. It means there's a real problem and you need to know about it. Concurrency, we've talked before. Things like timeouts and memory. What happens when a Lambda is a timeout? What happens when the Lambda exceeds the allowed memory? Things like that, you need alerts. By the way, some of the things here, like timeouts and memory, don't have any predefined alerts in CloudWatch metrics. So it's a bit more complicated, and you probably need an external tool, like Lomigo, for example, in order to define alerts for this type of errors. And iteratorage, a lot of people forget about it. Whenever your Lambda is connected to a Kinesis stream or to a DynamoDB stream, you probably want to know whether it takes a lot of time to read the message from that queue, because it means that there's a problem in your flow. Monitoring costs. Okay, so costs are very important in serverless environments. I always say that in serverless there's a trade between, let's call it, scalability and cost. What do I mean? In the old days, when you had 1 million requests per second, probably your system would die, okay? You didn't have enough compute power in order to handle it. Today, it won't happen. Today, there's a very good chance that everything will continue working, but you're going to pay a lot of money for that. So there's the trade-off, and you need to make sure you understand how much you're going to pay. So you can easily, if you're not looking after it, you can easily reach the end of the month, suddenly finding out that you're going to pay thousands of dollars to AWS, and to be honest, it's frightening and it's dangerous. So there are 3 reasons why your costs increase in serverless environments. First thing is, everything is going well. Actually, you have a lot of tractions, things are going well, you have a lot of users, and this is good. Okay, I hope you're making money, this is good. Second issue, you have a bug. Okay, so for example, it happened to me in the past that you have a recursive Lambda, a Lambda that does something that eventually you have a loop. That thing that you're doing is calling that the same Lambda over and over again. And it happened to me that I woke up in the morning, and then suddenly I found out that I'm going to pay another extra $1,000 because I had a bug in my code. And it was in a development environment, by the way. It wasn't production. So it's really scary. By the way, in such a situation, you can actually ask AWS to return you the money. I've done it before. You can show them that, hey, usually the workload in that environment is around, I don't know, $20 per month, and there was a bug here, and they return you the money. They are fair about it. And the third problem that might increase your cost is bad architecture. Again, using wrong resources, using wrong services while you need to use others. For example, you're using DynamoDB in order to store your objects. Bad idea. You probably need to use it. You probably need S3 in order to store your object. It will be much cheaper. So again, there are trade-offs here. Part of your job is understanding why things cost that so much money. You need to dig into your code, dig into your architecture, and understand why you're paying so much money. Tracing. You need to understand the story. Again, serverless environments are complicated. You need to understand what happens when something goes wrong. You need a way to understand why that specific Lambda didn't work. There's a very good chance that there isn't any bug in the Lambda, but the fact that it got, I don't know, an invalid input made it go, work unsuccessfully. You probably need a way to trace your code and go up the chain in order to understand what are the things that went before the different services and understand why things didn't work. So use tracing. And by the way, regarding tracing, first of all, you can either build the solution for yourself. Okay, they are very good. You can search for Jan Koy. There's a very great blog post he wrote about tracing your own code. So you can use it. And again, you can use automated tools that do it for you. And last but not least, learning. Guys, serverless, I think that the entire serverless world is very agile in itself. Things change really on a daily, weekly basis. I highly recommend getting up to date with blogs, podcasts, newsletters. I wrote you a couple of names, for example, Jan, Serverless Hero, by the way, works with Lumigo as a developer advocate. James and Jeremy writing great blogs, great podcasts. Listen to them, and of course the list is very long. There are a lot of great speakers. Make sure you learn new things every week. That's it. Thank you.
Okay, brilliant. Thank you, Efi. Right, questions, please. Go for it.
Hi, just wondering what automated tool you use for tracing?
Sorry?
Which automated tool did you use for tracing?
For what?
Tracing.
For tracing. So again, I can recommend Lumigo. This is one thing that can help you tracing your code. And in order to trace your code, there's a blog post. Actually, I'll update the presentation with a link to that specific blog post on how to implement it on your own.
Any more questions?
Yep. So languages, you mentioned something about more modern languages being more suitable. Which ones would you think are good for that?
Sorry?
Languages, programming languages.
So again, I highly recommend using Node.js or Python. And I think that also Go is very fast. And try to avoid Java and .NET.
Okay, great. So, thanks again, Efi. We'll do another round of applause.